Hello everyone. Today we will see one of the application of double integrals, that is to find the area of the given region. So the given region may be enclosed by some curves or maybe it may be enclosed by some lines. So to find the area of that region, we have to double integrate over that region. As here in the formula you can see that you can calculate the area by double integrating over that region. Here this r is used for that region. So just double integrate over that region dx dy. So now to evaluate this integration, we have to find the limits of this integration. So to how to find those limits, that we will see with one example. For the first example is find area of the circle x square plus y square is equal to a square. So as we all know that this is the equation of circle with center at 0 0 and radius is a. So we can draw the corresponding diagram on xy axis as this center is at 0 0 and this distance, that is the radius, that is a. Okay, so this point will be a comma 0 because the radius is a. So now here we will find the area of this circle. So for this we will find the area in the first quadrant only, because as the circle is symmetric diagram, so just by calculating area of this region and multiplying by this area by 4, we will get the area of this total circle. Okay, so just see this highlighted region. So now the same formula we will apply, that area is equal to double integration over that region r dx dy. So now the main important part is to find the limits. So in this given region we will consider a vertical strip, or maybe we can say that the strip which is parallel to y-axis. So see this strip in the given region. So this strip on along the x-axis, it varies from x is equal to 0 to x is equal to a. If you move the strip from left to right, on left it will coincide with x equal to 0 and to the right it will coincide with x is equal to a. So this will give the limit for x, that is x equal to 0 to x is equal to a, that is written over here. On this strip x varies from 0 to a. Okay, now to find the limits of the variable y. So you can see the ends of this strip. So this end, you can see that a lower end, this end is on x-axis. Okay, so x-axis is nothing but y is equal to 0. So from here you will get one limit for y. Here it is y is equal to 0 and the upper end is on the circle. Okay, the circle's equation is x square plus y square equal to a square. On solving this equation, that means y square will be a square minus x square. So taking the square root, y will be square root of a square minus x square. Like this, y square is equal to a square minus x square. So y will be equal to square root of a square minus x square. So this is the next limit for y. So this way we get both the limits for y, that is y from 0 to y is equal to square root of a square minus x square. So if you put this limit in the given integration, this will be 0 to a and 0 to square root of this dx dy. So now we have to evaluate this double integration. So for that, first we will evaluate this integration. So now to evaluate this integration, as these are limits for the variable y, as you can see y equal to 0 to y is equal to square root of a square minus x square. So we have to integrate this integration with respect to y. So this is written here, just separating this integration with respect to y. So first we will solve this integration within the square bracket and after that we will apply the outer integration. So this is just integration of dy, so that will be y and limits are from 0 to square root of this. So after putting the limits, it will be square root of a square minus x square only, because the lower limit was 0. Now this is the standard formula for integration of square root of a square minus x square. So you can easily get this formula, and remember this formula for integration of a square minus x square, that is x by 2 same square root plus a square by 2 into sine inverse of x by a. So this integration is completed here, and now you have to put the limits 0 to a, means First, at the place of x, put the value a. This is written in the first bracket minus lower limit, that is x is equal to 0. That is, in this bracket put x is equal to 0. You will get this second bracket. Okay. So if you evaluate this, square root of a square minus a square will be 0. So first term is 0. Second term is sine inverse of a by a, means sine inverse of 1, this a square by 2 as it is, minus a square by 2 sine inverse of 0 by a is 0. So further calculation is sine inverse of 1, that means sine pi by 2 is 1. So sine inverse of 1 will be pi by 2. Sine inverse of 0, as sine 0 is 0, therefore sine inverse of 0 is 0. So the calculation is pi a square by 4 only. So this was the area in the first quadrant only. So total area of the circle will be 4 times this area. So 4 will get cancelled out. The area is pi a square. Okay, so this is the area of circle. We have evaluated this by using the double integration. Okay. So the next question. Find the area of region bounded by x equal to 0, y equal to 4 and y equal to 2x. As in the previous example, we already known the diagram for the circle, but here we have to draw these 3 lines, as these are equations of lines, x equal to 0, y equal to 4 and y equal to 2x. So first, x equal to 0, this is the equation of y-axis. This means it is represented here, x equal to 0. Y equal to 4 will be a line parallel to x-axis, that is y equal to 4, and y equal to 2x. This is also a straight line, but to draw this straight line, we will take some points on this line. So I have explained it over here. To draw this line y equal to 2x, we will prepare a simple table of x and y. Take some values for x and calculate corresponding values of y from using this equation. So if you put x equal to 0, y will be 0. If you take next point, x equal to 1, y will be 2. And if you take x equal to 2, y will be 4. So these 3 points, that will be 0, 0, 1, 2 and 2, 4. These points are enough to draw this line. You can also take some more points if you want. So plotting these points, 0, 0 is this point. Now 1, 2, that means x is 1, y is 2. So here take some points 1, 2, 1, 2, 3, 4. So 1 and 2, this point is here, and next point is 2, 4. So x is 2, y is 4. So this will be somewhere here. So joining these 3 points will give us the line y is equal to 2x. So these are our required 3 lines. Okay. So after drawing this, you can see that we have to find area of this region, that is area enclosed by these 3 lines. So again we are going to apply the same concept. In the given region, consider a vertical strip. Okay. So this strip on the x-axis, it moves from left, it is x is equal to 0, and to the right, it is x is equal to 2. Okay. So it covers the area on x-axis at 0 to 2. And same for y-axis, we will be observing its end. So this end, that will be the lower end, will give the lower limit. It is on the line y is equal to 2x. So the lower limit for y is equal to 2x. And this upper end, this is on the line y is equal to 4. So it will give the upper limit for y, that is y is equal to 4. So this is the main important part, that is obtaining the limits from the given diagram. So these are our required limits. So next, the formula for area is again same, double integration over r dx dy. So now we have obtained the limits. X is from 0 to 2 and y is from 2x to 4. Again we will evaluate this integration first. So here, as these are the limits for y, we will first integrate with respect to y. You cannot interchange the order of the integration, as these are the limits for y. First you have to integrate with respect to y only. So integration, these integrations are separated. First we will evaluate the integration in square bracket. So that is integration of dy is y, limits are 2x to 4. So now just simply by putting the limits are also simple here. If you put y equal to 4, it will be 4 minus lower limit is 2x. So it will be 4 minus 2x. Now this is only a single integration in only one variable, that is x. So integration of 4 will be 4x minus 2 times integration of x will be x square by 2 from the limits 0 to 2. Now simply put the limits. First put x is equal to 2, so it will be this bracket, minus, if you put x is equal to 0, both terms will be 0, so minus 0. And after the calculation, you will get the answer as 8 minus 4, that is 4. So 4 square unit is the area of the region bounded by the given 3 lines. In this way, you can calculate area of any given region. So for that, first you have to draw the given region, and with the help of that region, you have to obtain the limits for the double integration. Okay, thank you.